Hello, 5th grade. This is Chapter 11, Lesson 8, page 845. Display measurement data on a line plot. Okay. Math in my world. 6 friends share several foot-long submarine sandwiches. The table shows the amount each friend ate. Make a line plot of the lengths in the table. We're going to make a line plot of these. 1/4 appears blank times. Excuse me. We got to count how many times it shows up in this box. It shows up 1 time, 2 times. 1/3 appears blank times. 1, 2, 3. 3 times. 1/2 appears 1 time. And I think that's it. Okay. Place the correct number of x's above each fraction on the number line. My throat is dry, sorry. Okay, 1/4. So 1x, I have to do 2 x's. 2. And I want to make them about the same size. I don't know, just so visually they kind of line up. 1/3 shows up 3 times. So 1, 2, 3. 1/2 appears 1 time. Add a title to the line plot. What would that title be? Just out of curiosity, let's see what this thing says. Too much. Okay. All right, so what is this all about? It's 6 friends shared several foot-long submarine sandwiches. The table shows the amount each friend ate. Make a line plot of the lengths in the table. So sandwich lengths was the name of this, and it's going to be the name of our line plot also. Sandwich lengths. Oops, I wrote on top of it NG, lengths. In feet. Okay, got that. So that's a line plot. Let's see what we need to do next. You can find the fair share, or the amount each friend would receive if the sandwiches were divided equally. First, add the measurements to find the whole, like how much there is altogether. And then divide the whole by the number of measurements that were in the box, in the table. Okay, so fair share is like finding the average amount someone ate. So fair share means it's fair among everybody if you were to find the average length. So, let's try that. Find the fair share using the line plot from example 1. So we already did it, number 1. And it says, add the fractions to find the total amount of sandwiches that were eaten when you put it all together. Add the fractions with the like denominators first. So they said there was 2 x's above 1/4. So 1/4 plus 1/4 is 2/4, or when you simplify it, it becomes 1/2. There were 3 people, or 3 x's above 1/3. So they had 1/3 plus 1/3 plus 1/3, which is 3/3, which anything over itself equals 1 whole. And then there was 1 x above the half. So that's easy, that's just a half. Now we have to combine that all together. We've got 1/2 plus 1 plus another half. 1/2 plus 1 plus another half. 1/2 and 1/2, these two make a whole. So it'd be 1 whole plus 1 whole is 2 whole sandwiches were eaten. Divide the total amount by the number of x's that were on the plot, the line plot. So 2 whole sandwiches divided by 6 people who were eating them, or 6 numbers that were in the plot. And you got to figure out what 2 divided by 6 is. It's not an even number, it's going to be a fraction. So we will, let's see what this says. Divide the total number of x's on the line plot. Find 2 divided by 6. You can draw a model. So they have 2 here. They're dividing it into thirds. 1, 2, 3 thirds. 1, 2, 3 thirds. Each piece represents 1/3 of a sandwich. So if the sandwiches were divided equally, each person would have eaten 1/3 of a sandwich. Let me double check my work. Okay. Well, that doesn't, I don't know if that makes that much sense to you. So let's just look at this. I was trying to do 2 divided by 6, which I was looking at and I'm like, well, I'd need a decimal, and then it starts getting a little funny. But you could just think of it as 2 divided by 6 like that, because every fraction is a division problem, 2 divided by 6. And then you could just simplify it. If you divide by 2 on top and divide by 2 on the bottom, 2 divided by 2 is 1. 6 divided by 2 is 3. And that's probably where they got 1/3 for dividing their sandwiches into thirds. And I just like seeing it that way better. That's where it came from. Anyway, let's try another one. But I'm going to move over here. Independent practice. Okay, it's all about plotting on a line and then finding the fair share, which is another word for finding the average of the measurements. Make a line plot of the measurements in each table and then find the fair share. Here we go. First of all, you got to figure out what numbers to put across the bottom. So, I see 1/4, half, third, 3/4. These are all things that need to be displayed across the bottom. Preferably in order from small to large would be nice. The largest one seems to be 3/4. That's, we could do that one over here. I see a half, which would be like in the middle. I see fourths and I see thirds. A fourth is smaller than a third, so I'll go in this order. So I've labeled my line. Now I need to put X's above them. 1/4. How many 1/4s are there? I guess I'll circle it as I use them. 1, 2, 3, 4. 1, 2, 3, 4. Now I'm going to look for my thirds. 1, 2, 3, and that seems to be it. 1, 2, 3. I was trying to make my X's around the same size so that when I have 3 and 3, they kind of line up. It's just a nice visual to see which one is winning in the race for who's got more, which one was used more. Halves. 1, 2, 3. 1, 2, 3. And then 3/4, I've got 2 of those. 1, 2. 1, 2. Okay. You can see 1/4, there's more of those than the others. Now we need to add them all up and find the fair share, which is the average. So we're going to add all these fractions up, and then we're going to divide it by the number of X's, or the number of items that were added together. I'm going to use my whiteboard just for more space for working on. So here we go. I've got 4 1/4s. So 1/4 plus 1/4 plus 1/4 plus 1/4. Do you see? I can see what that is already. 1, 2, 3, 4 out of 4 equals 1. So that's a nice easy number to work with. Okay, let's see, we have thirds, 3 1/3. Well, I can see the book meant for this to happen too. Someone's doing some thinking ahead of time. LOL. There's exactly 3/3. 1, 2, 3 thirds, which is also equal to 1 whole. So if we're talking sandwiches, those all added up to a sandwich. These all added up to a sandwich, for example. Halves, 3 halves. Well, that one's not going to work out evenly, but halves are easy to like visualize. So if there's a half extra, that's okay. 1 half plus 1 half makes 1 whole. This is 1. Plus another half equals 1 1/2. Easy number to work with, half. And then we have 3/4. There's 2 of those. 3/4 plus 3/4. You add the numerators. 3 plus 3 is 6. The denominator is 4. This one is improper, so we need to fix that. We need to divide the top by the bottom. 6 divided by 4. 6 divided by 4. 4 goes into 6 one time. Subtract, you get 2. That is your remainder. So it's 2 over 4. So it's 1 2/4, which is also the same as 1 1/2, because 2 is half of 4. Or if you divide by 2 on top and 2 on the bottom, 2 divided by 2 is 1. 4 divided by 2 is 2. So this is equal to 1 1/2, the 3/4. Now you have to put all those together. So we've got 1 plus 1 plus 1 1/2, 1 plus 1 plus the 1 1/2 plus the other 1 1/2, for a total of, I'm going to do all the wholes first. 1, 2, 3, 4. And these 2 halves nicely go together to make another whole. So it's actually not 4, it's 5. It was 1, 2, 3, 4, and then these 2 go together to make 5 whole. So your total is 5. All of these add up to 5, and we have to divide by the number of x's that we had in our problem. You could count them, or you could count these, because these x's represent these. So I'm going to count up here in case I did anything. Well, I don't know. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's this number divided by 12. Everything that it added up to divided by 12, which actually I need to do in the form of a fraction. So we'll do 5 divided by 12, 5/12. Do they have anything that divides into the top that divides into the bottom? Anything in common? No. So our final answer is going to be, the fair share would be 5/12, because this cannot be simplified. It's just 5 out of 12. And I will check my answer, check my work. The fair share would be 5/12. Seems like a strange answer, but I'm going to double check. Hopefully I didn't make a mistake. Yep, it's correct. 5/12 of a foot. It just seems like a strange answer for someone who's just learning this. I thought it would come out nice and neat and even, but it's 5/12 of a foot. Okay, let's continue. I thought it would come out like a whole number, or a nice fraction like a fourth or something. 5/12 is not common. Anyway, erasing my work so I can do some more. Iced tea. Okay. This is quarts. On here, I need to represent fourths, eighths, halves, and that's all I see. And I like to put them in order. So a fourth is smaller than a half, an eighth is smaller than a fourth. So I'm going to go 1/8 first, 1/4 next, and 1/2 last. Now I'm going to put in the x's. I guess I could just go in order. So how many halves are there? 1, 2, 3, 4. 1, 2, 3, 4. Now I'm going to do the fourths. 1, 2, 3. 1, 2, 3. Now I'm going to do the eighths. There's 2 left. I'll circle them for fun. 1, 2. It's official. 1, 2. Okay, visually, line plots are nice because I could see that the winner here is 1/2. And if people drank these amounts, some people drank a half of a quart, someone drank a fourth, some people drank an eighth. A lot of people, more people drank a half, 4 of them. But we need to find out the average. What's the average of this? Is it going to be closer to a half or closer down here or right smack in the middle? Let's find out. We need to add all of these fractions up, every single one of them, and then we need to divide by the number that were put together. So there were 1, 2, 3, 4, 5, 6, 7, 8, 9. Whatever my answer ends up being, it's being divided by 9 entries. So time to put these together on my whiteboard. Okay, here we go. There are 4 1/2s. Halves are easy. 1/2, 1/2, 1/2, plus 1/2. 1/2, 1/2 is 1. 1/2 and 1/2 is 1. Put them together, you have 2. So that's 2 whole. Okay, I got my halves done. Let's do my fourths. There's 3 of those. 1/4, another fourth, another fourth. 1, 2, 3. That adds up to 3 over 4. Okay, that's done. And then I have my eighths, 2/8. I can just say 2/8, but 1/8 plus 1/8 equals 1 plus 1 is 2/8. These could be simplified so that they could be put together now, because once I figure out each of these, I have to add this plus this plus this. I'm going to convert them into something that is common on the bottom. So I think I'll reduce this one. If I divide by 2 on the top and divide by 2 on the bottom, it becomes 2 divided by 2 is 1, 8 divided by 2 is 4. This is reduced down to 1/4. That could be added to 3/4, so that works. So it's going to be 2 whole plus 3/4 plus 1/4. I'm writing it sideways just so you could see it. I'm going to put these two together. 3 plus 1 is 4, and the denominator stayed the same, plus the 2 that was already there. 4 over 4 is the same as 1 whole, so it's basically 2 plus 1, which equals 3. So the total of all that ended up adding up to 3. That's your final answer for that. Well, you have to divide it by the number of fractions that were put together in our line plot. And there was 1, 2, 3, 4, 5, 6, 7, 8, 9 fractions that were entered. So it's 3 divided by 9. And I know that 3 is a multiple of 9. So I can just simplify it. 3 divided by 3, 9 divided by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. The final answer ends up being that the fair share is 1/3. The average of these numbers, the fair share, is 1/3. So if you're going to drink either anywhere from 1/8 of a quart to a half a quart, 1/3 would be the average of that. And if a fourth is here, 1/3 would end up somewhere, probably like in here somewhere. Anyway, there you go. Trying to decide what we want to do next. There's a lot of numbers here. Let's do this one and then we'll call it done. Last one. Okay, I see eighths, fourths, halves. I see 7/8, 3/4. Wow, there's a bunch of them. Okay, each one of them needs to be represented on the line. I like to do them from smallest to largest, so let's give this a try. If you have 3 out of 4, that's bigger than a fourth. 3 out of 8 is bigger than an eighth. 5 out of 8 is bigger than an eighth. So let's try and get them in order. 1/8 is the smallest. I see fourths. This may not be my perfect line plot. Let me just check something for a visual. Okay, I got my eighths, I got my fourths. I'm going to need a half. I'm going to put that over here. I see 7/8. 7/8 is like almost a whole, so I'm going to put 7/8 over here. It's 7 out of 8 pieces. 3/4 might be a little less than that, so I'll put 3/4 in here. I see 5/8. Oh boy, this is getting tight. I'm looking at like the teacher's guide, 5/8 they have in here. So I'm getting a little tight, but this is, I'll draw my line here. This is the 5/8. Okay, are they all represented? I think so. Could I have drawn it better? Yes, but I don't have a pencil, so we're going to keep on going. Okay, let's see how many of each. 1/8. 1, 2, 3, 4. That's all I see. 1, 2, 3, 4. Now I'm going to my fourths. 1, 2, 3, 4. I see 4 of those. 1, 2, 3, 4. If I missed one, could I fix it later? Of course. Here we go. Halves. 1, 2, 3. I see 3. 1, 2, 3. 5/8. Let's see. How many of those are there? 1. Is there another one? Nope. Just 1. 3/4. 1. Is there another one? Nope. 7/8. 1. That's it. And then I missed something. There's a 3/8. So for the sake of space, I'm going to put it in here. 3/8. If I was handing it in for homework, if I were handing it in, I would probably want to redo this and make sure they're in order of smallest to largest, but this will do. Okay, it's not in a bad place. It actually might even be accurate. 1, 2 of those. 1, 2. Okay, I got them all. Now I need to add all these things up. How fast can I do this? And could I just, well, we're teaching you out loud, but technically I could maybe try and do some of this in my head, but I've got 1, 2, 3, 4 1/8 pieces. It's sort of, I could probably just do 1/8 times 4 or add them all up. Let's do it times 4. Maybe that'd be better. That'd be like 4/1. 4 times 1 is 4, and 8 times 1 is 8. Multiplying 4 times 1/8 is the same thing as adding 1/8 plus 1/8 plus 1/8 plus 1/8. I'm just multiplying it out 4 times. So that's that. These eighths simplify down to 1/2 because 4 is half of 8. Okay, got the eighths. How about the fourths? There's 1, 2, 3, 4 of those guys. I'm going to do the same thing. 1/4 times 4. And when you have a whole number, it's basically over 1 anyway. 4 times 1 is 4. 4 times 4 is 4. 4 over 4 is the same as 1 whole. 3/8, there's 2 of them. 3/8, I'll just write this one out, plus 3/8. 3 and 3 is 6 over 8. When I'm adding, the denominator stays the same. This could be simplified by dividing 2 into the top and 2 into the bottom. 6 divided by 2 is 3. 8 divided by 2 is 4. Okay, that's 3/4 when it's simplified. Now I'm doing halves. There's 3 of them. 1/2. I'll just add it going this way because it's a nice visual. 1/2 and 1/2 is a whole, plus another half would be 1 1/2. I'm running out of time on my video. 5/8. We've got 1. All right, I'll just write 5/8 down here. The lone 5/8. 3/4. The lone 3/4. 7/8. The lone 7/8. There's only one of each of those. All of these need to be added together. So I see, I have to find things that can go together. Let's start up here. I know a 1/2 and a 1/2 could go together. That'd be 1 whole. So these two make 1 whole plus this one would be 2, plus this one would be 3. I'm doing all the wholes. That's 3, plus this would be 3 3/4. That's what all these 4 add up to. Now I have to add these on. So far I've got 3 3/4. 3 3/4 plus these guys. I see a couple of eighths. Let's put these two together. If I have 5 plus 7, that's 12 eighths. This can reduce. What's 12 divided by 8? 8 goes into 12 one time. Subtract. 12 take away 8 is 4. 4 eighths is what's left over. 4 over 8. So it's 1 4/8, which is the same as 1 1/2. So this and this make 1 1/2. So I'm going to put that here and add that on. I'm trying to get them all together. And this is the last thing I have left. 3/4. I need to get this all put together. Look at all these steps. I can do... I'm just thinking where to start. I guess I will do these two together. 3 plus 3 is 6 with the 4 in the bottom. G. 6 divided by 4. I mean, some of this could be done mentally, but I'm just like feeling like I need to teach it. So 4 goes into 6 one time. Subtract and you get 2. And you take that remainder and put it over the 4, and that is actually equal to 1 1/2 when you reduce it. So this and this make 1 1/2. So now it's 1 1/2 for these two, plus the 1 1/2 that is there, plus the 3 that didn't get used yet. I have to add this on in the end. So 1 1/2, 1 1/2. Can you figure out that these two together, 1/2 plus 1/2 is 1, plus this guy is 2, plus that's a total of 3. This makes a total of 3 whole, so I've used that up. Boy, this gets messy. And then I had the 3 that was sitting there. So 3 plus 3 is 6. The total of all these things added together is 6 whole, just 6. And it needs to be divided by the number of x's in the problem. So, gee, that's a lot of work. I mean, it's just so much to write. So we got 6. All of these added up to 6. Let's count how many were in the box. 2, 4, 6, 8, 10, 12, 14, 16 things. It's a total of 6 divided by 16 entries. Entry numbers, 16 entries, 16 x's. This is how it's going to look, but you just reduce it. So this could be divided by 2. This could be divided by 2. 6 divided by 2 is 3. 16 divided by 2 is 8. Your final answer ends up being 3/8 is the average or fair share. 3/8 is the average of all those fractions. 3/8 ends up being the average, and it's like the middle of this grouping, but that was the average amount of sliced turkey per pound that maybe someone ate or anyone ate. The average or fair share is 3/8 of a pound. LB. This one probably should have been labeled quart. Whew. Okay. The buzzer's off and my time is up. I will see you in the next lesson.